For our last lesson of the unit, we're going to be looking at triangles in the coordinate plane. But before we get to that, I want you to remember something you probably learned about triangles a long time ago, and that's that in order for three lengths of a triangle, or three sides, to make a triangle that meets, two of the sides cannot be shorter than the longest side when we add them together. So if you can kind of picture A and B swinging in towards line C, they're never going to meet. Like, they're just going to lie on top of the line and they'll never make a triangle. So if A and B add up to a number bigger than C, it can't be equal to, because then you just have a straight line also, then you can make a triangle from those three sides. So our next type of triangle problem is where we're given three vertices, A, B, and C, and we have to determine, is this a scalene, an equilateral, or an isosceles triangle? Now, if you didn't bring a lot of scratch paper to this lesson, I'd recommend it because we're going to be doing a lot of the distance formula, midpoint formula, and finding slopes, so it's worthwhile to have a few extra pieces of paper lying around. Now, to sketch this out, I just drew two axes really quick, plotted where I think A, B, and C would be, approximately, and I made a hypothesis. My hypothesis is that this is either an isosceles or an equilateral triangle. I noticed that 0 to 12 is the distance from A to B, so 12. And C appears to be 6 up, so it seems to be on the midline, which would make it the perpendicular bisector, which means it has to at least be isosceles, but we're going to prove it anyway. So to find BC and to find AC, what I'm looking for is using the distance formula. When I plugged that in, I found that both were equal to the square root of 72, which means that triangle ABC is only isosceles, because the square root of 72 is definitely not equal to 12. That would be the square root of 144. So this is the first type of problem. We're using the distance formula to calculate each length, but if you have an easy one, like this was a vertical line, you can use other methods to find the distance. Our next type of question involves a slightly more challenging one, where they were a little more vague. What kind of triangle is PQR? So now we have to figure out, is it scalene, isosceles, or equilateral? And I'd also like to check, is it a right triangle? So again, we're doing the distance formula, and I found that PR is equal to QR. They're both equal to 5. But QP is equal to the square root of 50. So this is an isosceles triangle. Now, if you want to check if something is a right triangle, you're looking at the corner, or the vertex, that is opposite the longest side. So the square root of 50 is bigger than 5, or the square root of 25. So we're looking at the side opposite of QP, or the corner that is opposite QP, and that's R. So I want to see if the line segments that make up R are perpendicular to each other. In other words, is QR perpendicular to PR? So to do that, I found the slope of each one, and I got slope of QR is negative 3/4, and the slope of PR is positive 4/3. A way to check if these are opposite reciprocals is to multiply them. If you get -1 as your result, then you know that it is a right angle, or that they are perpendicular lines. So these are two perpendicular line segments at R, which means that this is indeed a right triangle. And so the most specific classification for PQR is that it is an isosceles right triangle. This type of problem is related, and we're going to need this when we get into class. What is the equation of the line perpendicular to M that passes through point R? We're going to use this sort of problem when we're finding the area of a triangle that doesn't have a very obvious base and height. First, we want to find the slope of line M. So I've marked 2 points that were pretty obvious on the line, -2, -2, and +3, +2. Calculating the slope, we get +4/5, which means the perpendicular slope, or the opposite reciprocal, is going to be -5/4. The easiest way to write the line that is perpendicular to this is in point-slope form. So all I'm doing is I wrote down where point R is, and I plugged it into point-slope form. When I got to the slope section, I made sure to put in the perpendicular slope so that it matches the answer to the question. The last type of question we have, I'm going to show you 2 different ways to solve this one. We're asked to find the area of triangle ABC. Now, the 2 types of areas that are the easiest to find are if it's a right triangle or an isosceles triangle, especially if it's a right triangle. So first I wanted to check if it's right or isosceles. First I checked isosceles. It looks like AB and BC could be equal to each other. And indeed they are both equal to the square root of 10. Excellent, this is an isosceles triangle. I also checked if AB and BC make a right angle. AC seems like the longest side, so B would be the natural place for a right angle. Slope of AB was 1/3, and I just counted that from the graph, up 1/3. The slope of BC was -3, down 3/1. Because these are opposite reciprocals, this is also a right triangle. So I'm going to show you 2 different ways, and I'd recommend you write down the method that is, well, the shortest, because frankly, you don't need 2 methods on this exact problem, but I'm just using this as an example. So a right triangle means that the base and the height are already perpendicular to each other. So the base I'm going to use is AB, and the height I'm going to use is the section that's perpendicular to it, BC. When I plug those in, the square root times the square root of itself equals the number that's inside. So 1/2 of 10 is 5 square units, is our area. Now, if all I knew was that this was an isosceles triangle, we know that the line or the altitude from B to the midpoint of AC is going to be perpendicular. That was one of the theorems that we learned earlier in this unit. So I need to find the midpoint of AC because I know that the midpoint will be the point perpendicular through B that makes the base, or the height rather. So if I find the midpoint of AC, it's at 0, 2. That's nice. Nice easy numbers. Next, we need to find the distance from B to M, and we're going to use that as our height. I got the square root of 5. For our base, we're going to use the distance from A to C, which I got square root of 20. And last, we plug it in. Square root of base times height. Now, you can just do the square roots in your calculator. I used a method that you'll learn for simplifying square roots. And I also got 5 square units, so it works either way for this problem because we had an isosceles right triangle.